Good morning, dear students. Welcome back to physics class. Today, I would like to present a new concept, significant figures. Today's discussion topic is significant figures part A. For last two classes, you have been hearing about arrays and their roles in measurements. Today class, I am going to discuss on new concept, the significant figures. What are significant figures? What are their importance in measurement? You know that it is impracticable to make absolute or ideal measurement because every measurement involves error. It is also an important thing that once result is reported, it should show the precision of its measurement. So, every measurement results in a number that includes reliable digits and uncertain digits. What are reliable digits? Reliable digits are the digits which do not involve uncertainty or error. Then, uncertain digits are the digits which includes errors, which means that they are not reliable. Normally, the reported result of measurement is a number that includes all digits in the number that are known reliably plus the first digit that is uncertain. Reliable digits plus the first uncertain digit are called significant figures or significant digits. This indicates the precision of measurement which depends on least count of measuring instrument. For example, if you are given a period of oscillation of a pendulum is 1.92 seconds. Here 1 and 9 are reliable and 2 is uncertain. Thus, the measured value has 3 significant figures. Now, you are going to study about the rules which are used for determining number of significant figures. There are mainly 5 rules which are commonly useful. First rule is all non-zero digits are significant. Second one is all zeros between two non-zero digits are significant irrespective of decimal place. That is, this kind of zeros are significant no matter where the decimal point is, if at all. For example, you are given a question. You count and say the number of significant figures in this number. Number is 9,50,025. No doubt to say it will be 6. You have counted 2 zeros also to state the total number of significant figures. It will be 6. Third rule is for a value less than 1, zeros after decimal and before non-zero digits are not significant. Here, 0 before decimal place in such a number is always insignificant. For example, if you are given a number 0.005802, you have to count and say how many significant digits are there. You can say there are 4. You see the number again, the underlined zeros are not significant. Fourth rule is trailing zeros or the terminal zeros in a number without decimal place are insignificant. For example, the value of measured length of a table is given you. It is 1.5 meter. If you express this value in CGS system, it will be equal to 150 centimeter, and if you convert this value in millimeter, it will be equal to 1500 millimeter. Thus, 1.5 meter is equal to 150 centimeter is equal to 1500 millimeter. And it has two significant figures, whatever the system of units have used to express this value. This rule shows the trailing zero or zeros being not significant. And fifth rule is trailing zeros in a number with decimal place are significant. For example, can you say how many significant digits are there in these numbers? The numbers are 8.1000 and 0.004900. You can say these numbers have 5 significant figures each. Here you have counted the trailing zeros or terminal zeros because these numbers are having decimal places. Another example is given. If you are given a number 7500.00, you have to count and say how many significant digits are there in this number. No doubt to say it will be 6. You have to remember the usage of these 5 basic rules to determine the number of significant digits or significant figures of a given number or set of numbers appropriately. And also, you have to recollect that a choice or change of different unit system does not change the number of significant digits or significant figures in a measurement. For the practical usage of this knowledge, let you see how to solve this question. Question is, how many significant digits does each number have? First one, 2,20,058. Second one is 7,29,100. Third one is 0.000092525, and fourth one is 19,407.000. What is its solution? The numbers are given. First one is answer 6. There are 6 significant digits. Here we have used rule 1 and rule 2. Second one answer is 4 significant digits. Here we have used the rule 1 and rule 4. Third one answer is 5 significant digits. Here rules 1 and 3 are used. And fourth one answer is 8 significant digits. Here we have used the rule 1, rule 2 and rule 5. Next discussing part is expressing a measured value in scientific notation. What is importance of expressing measurement in scientific notation? You have to know a very important fact that there can be some confusion regarding the trailing zero or zeros. Suppose a length is reported to be 4.700 meter. It is evident that the zeros here are meant to convey the precision of measurement and are therefore significant. If this were not, it would be superfluous to write them explicitly. Now we can express this value in other system of units. They are 470.0 centimeter, 4700 millimeter and 0.004700 kilometer. From the number 4700 has trailing zeros but with no decimal. We should consider the number has two significant figures when its value expressed in millimeter, while in fact it has four significant figures and a mere change of units cannot change the number of significant figures. To remove such ambiguities in determining the number of significant figures, the best way is to report every measurement in scientific notation. That is, it should be in the power of 10. What is ambiguity? Ambiguity means the confusion. This is the importance of expressing the measurement in scientific notation. Let me discuss how to use scientific notation to report such measurements. From previous part, you have understood that change of units should not change number of significant digits, and also you noted that first two quantities have four significant figures, that is, when the same physical quantity length is expressed in meter and centimeter, but third quantity has two significant figures. Here, this value is expressed in millimeter. How can we express a number in scientific notation? Numbers should be expressed in powers of 10, that is, number should take in the form of a into 10 the power of b, where a be a number which is lying between 1 and 10 and b is any positive or negative exponent or power of 10. And you note that b is called order of magnitude of that measured quantity. To solve the issue of the previous problem, let us consider the same example again. 4.700 meter is equal to 4.700 into 10 the power of 2 centimeter is equal to 4.700 into 10 the power of 3 millimeter is equal to 4.700 into 10 the power of minus 3 kilometer. In all the above, power of 10 are irrelevant. The word irrelevant stands for not important. In this case, the power of 10 in all the numbers cannot determine the number of significant figures, so they are irrelevant. Here, the number of significant figures of the quantity in all system of units are 4. We have expressed the number of significant figures of the same quantity successfully using the scientific notation. You have to note that no matter whatever the system of unit is used to express the value of the same physical quantity. In order to get an approximate idea of a number, we may round off the number in such a way that a can be converted into 1 by the condition of a less than or equal to 5, or a can be converted into 10 by the condition of 5 less than a less than or equal to 10. That is, in second condition is that a should be greater than 5 but less than or equal to 10. Then this number can be expressed approximately as 10 the power of b, in which the exponent or power b of 10 is called order of magnitude of the physical quantity. When only an estimate is required, the quantity is of the order of 10 the power of b. That is, this exponent shows the magnitude of the physical quantity. As I told earlier, the power or exponent of 10 in scientific notation of that physical quantity cannot determine its number of significant figures. For example, the diameter of the earth, it is equal to 1.28 into 10 the power of 7 meter, which is of the order of 10 the power of 7 meter with the order of magnitude 7. The diameter of hydrogen atom is 1.06 into 10 the power of minus 10 meter, which is of the order of 10 the power of minus 10 meter with the order of magnitude minus 10. You have to compare their order of magnitudes and say that by how many orders the diameter of the earth larger than the diameter of the hydrogen atom. You can say that the diameter of the earth is 17 orders of magnitude larger than the hydrogen atom. By this way, we can get an approximate idea of a number using the scientific notation. In the scientific notation, no confusion arises about the trailing zero or zeros in the base number a, because they are always significant. Thus, it can say that the scientific notation is ideal for reporting measurement. But if this method is not adopted, we use the previous rules in given situations. First one is for a number greater than 1 without any decimal, the trailing zero or zeros are not significant. And second situation, for a number with a decimal, the trailing zero or zeros are significant. Let me see what are the two more observations and how to use the rules. The observation one is the digit 0 conventionally put on the left of a decimal for a number less than 0 is never significant. For example, consider the number 0.1250. Here, the underlined 0 is insignificant. However, the zeros at the end of such a number are significant in a measurement. Observation 2 is multiplying or dividing exact numbers can have infinite number of significant digits. For example, consider a problem to find radius of a circle. Radius is equal to diameter by 2. Here the factor 2 is an exact number, and 2 can be written as 2, 2.0, 2.00, 2.000 and so on. Thus, the quantity diameter when it is divided by 2 can have infinite number of significant digits. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.